symmetric key cryptography, that is DES algorithm, data encryption standard algorithm, which is a very familiar algorithm of encryption. And the next thing we'll be seeing asymmetric key cryptography, that is DH algorithm. So Diffie-Hellman algorithm. So these two algorithms we are going to deal with in today's class. So the main objective of today's session is that to make you known about the symmetric key cryptography algorithm, that is DES, data encryption standard algorithm, and the asymmetric key cryptography algorithm, that is Diffie-Hellman algorithm. So in yesterday's session, we have seen the asymmetric key cryptography algorithm, it is RSA, reverse Shamir-Adleman algorithm. Okay. So today we are going to see the asymmetric key algorithm, that is DH algorithm. Okay, fine. So the outcome of this session is to the students may be able to understand the DES algorithm and the DH algorithm. So these are the outlines of today's session. So first we will be dealing with the symmetric key algorithm, that is DES, data encryption standard algorithm, and all about the steps involved in encryption as well as in decryption, and what is the strength of the DES algorithm, and what are the variations, that is types of DES involved. There are two types, one is double DES, the other one is triple DES. So under the triple DES you are having two more types. The first one is triple DES that uses 3 keys, and the second one triple DES that uses 2 keys. So these are the variations that comes under DES, and next we will be seeing the asymmetric key cryptography algorithm, that is the Diffie-Hellman algorithm. Okay, now how it works and what are the advantages, disadvantages, and where we can apply this DH algorithm, and conclusion. Okay, fine. Okay. So as far as two basic techniques used for encrypting the informations. The first one is symmetric encryption, and the second one is asymmetric encryption. So these, as we have seen all these in the prior session itself. So symmetric encryption is otherwise called as secret key encryption or private key encryption. And asymmetric encryption is also called public key encryption, or else public and private key. Since asymmetric key encryption uses 2 keys, one is the public key and the private key. In case of symmetric encryption, we'll be using only 1 key, that is a single key, that is common secret key. So here you can clearly the working of symmetric and asymmetric encryption algorithm is depicted in the first thing, that is, so plain text is given as input for the encryption, and with the single key, that is the common key which is used for both the encryption and the decryption process. Okay, and you will get after encryption, you get the ciphertext that is given as input for the decryption process, and with the help of the same key, the ciphertext will be decrypted and converted into the plain text. So this is what happens in symmetric encryption. So using of a single common, that is the same key will be shared for encryption process and the decryption process. That is symmetric key encryption algorithm. Okay, fine. And coming on to the asymmetric, will be using for encryption, public key will be used, and for decryption you will be using the private key. Okay, So see here, the plain text is encrypted with the help of the recipient's public key, and it is converted into ciphertext, and this ciphertext is given as input for the decryption process. So at this stage, the recipient's private key is used for decrypting the ciphertext, which will be converted into the original plain text again. Okay, so here two keys will be used. One is the public key and the private key. Okay, so private key will be used for decryption process and public key will be used for encryption process. So coming on to the classification of encryption, you are having symmetric and asymmetric. Coming on to the symmetric, you will have classification as stream cipher and block cipher. Okay. So stream cipher is a symmetric key cipher. In this stream cipher, all the plain text will be, so each plain text is encrypted at one at a time with the corresponding digit of the key string to get the digit of the ciphertext. That is, each digit will be processed. Each digit of the plain text will be processed and converted into the ciphertext. So digit by digit encryption is done at the stream cipher. Okay, so this encrypts digital data stream 1 bit or 1 byte at a time. That's the main point to be noted in stream cipher. So the example for stream ciphers are auto-keyed Wagnerius cipher, Vernam ciphers. Okay. So the alternative name for stream cipher is state cipher. Okay. So as the encryption is dealt with each and individual digit or bit by bit, it will be get encrypted. Okay. Fine. So coming on to the stream cipher process, see, Alice is going to transfer the message to Bob. So he'll be using the encryption key, and which gets converted into ciphertext, and Bob will be using the decryption key. Okay, fine. So here, Bob is sending the message, "Hello, Alice." So Bob will be do the encryption process with the Alice public keys, and it will be converted into ciphertext. And at the other end, Alice will be go for decrypting with her own private key. Okay, so as similar to the working process symmetric key process, we have seen two keys will be used for the encryption. Recipient's public key will be used for the encryption process, and at the decryption side, recipient's private key will be used for the decryption process. That's a process to be done. Okay. Coming on to block cipher. So stream cipher means each bit by bit encryption process will be done. So here block means it's a combination of bits, we can say that like that. Okay, so a block of plain text is treated as whole, and it will be converted into ciphertext block of equal length. Okay, so for example, if you're doing the encryption a block size of 64 bits, means you will get the 64 bits of ciphertext. Or in case if you are using 128 bits for encryption, then you will get the ciphertext 128 bits. Okay. So as with the stream cipher, two users share the symmetric encryption key. So the majority of the network-based symmetric applications will make use of this block cipher. Okay. So here you can see the same thing. I am repeating the same concept once again. So files can be encrypted with the public key and it can be decrypted with the private key, as we have seen in the previous one. Okay. So Alice is going to encrypt the data for Bob. So she will be using the Bob's public key for encryption, and at the decryption process, the Bob will be using his own private key for the decryption. Okay. So this is what the working of a stream cipher and the block cipher. So here you will be having the bit stream generation algorithm will be applied for the encryption process, whereas so plaintext will be given as input for the encryption, and this bit stream generation algorithm will be given as input, and K is the key used. Okay, so with all these encryption will be processed and converted into ciphertext CI, and at the decryption ciphertext is given as input and bit stream generation algorithm is applied onto the decryption process and getting back the plain text. Okay, so block cipher you'll be getting the same thing. Plain text will be consisting of B bits. Okay, so B bits we call that as a block. N number of bits going to be called as a block. Okay, and we'll get the block of bits as the ciphertext. If you are using 126 bits, then as the plain text, then 126 bits will be getting as ciphertext. Okay. So here you can see the n bit block substitution. Okay. So here n representing 4 bits. So here each block is representing 4 bits. So the block cipher will act upon the plain text block of n bits to produce a n bits of ciphertext block. Okay. So there are 2 power n possible different plain text blocks can be used for encryption. Okay. And each will produce the unique ciphertext blocks. Okay. So coming on to the data encryption standard, which is a symmetric key cryptography algorithm. It's widely used encryption algorithm. Okay. So DES uses 2 basic techniques of cryptography. The one is called as confusion, otherwise called as substitution, and the second one is called as diffusion, that is called as transposition. Okay, fine. So substitution and transposition. Okay. So at this simplest level, diffusion process is achieved through the permutation calculations. Okay, and confusion is achieved through the XOR operation. So please make a note of this. So these 2 techniques are used, confusion and diffusion. Diffusion we are going to do with the permutation calculation, and confusion we are doing going to do with the XOR operation. Okay, fine. So let's move into the DES algorithm, how it works. Okay. So on the right hand side, clearly the working process is depicted as picture. Okay. So we'll move with one by one theoretical part along with the picture. Okay, fine. So this data encryption standard algorithm was developed in the year 1970 by the National Bureau of Standard, NBS. So with the help of the NSA, that is National Security Agency. Okay, and this DES is a block cipher method. Okay, fine. So block cipher means, so the bits, some n number of bits will be considered as one block. Okay, so if you are taking the plain text as 64 blocks, then you will be getting the output ciphertext as 64 block. 64 bits of 64 bits block. Okay, so we call this DES as a block cipher method. Okay, fine. So it encrypts the data in block size of 64 bits each. Okay, so each block will be consisting of 64 bits. Okay, so it produces 64-bit ciphertext. So the same algorithm and the key will be used for encryption as well as the decryption process. DS can be used, DS algorithm with the key can be used for encryption as well as for the decryption process. Okay, and out of 64 bits, you can use the key length as 56 bits. Okay, fine. The key originally consists of 64, but the key length use it as 56. So, however, only 56 of these are actually used by the algorithm. The rest of the 8 bits we can use it for checking the parity bits, and therefore can be discarded also. So, hence we are going to, the algorithm is going to use effectively use the key length of 56 bits. Okay, fine. So this algorithm is going to consist of 16 steps. So each of which is called as a round. So here you can clearly see that rounds. So 16 steps has to be proceed. So this 16 step is equivalent to one round. Okay, fine. And each round will be performing the steps of substitution and transposition. So this DS algorithm mainly based on the two fundamental attributes. The first one is substitution, which is called as a confusion, and transposition, which is called as a diffusion. Already we have seen DS algorithm is based on two techniques. One is confusion and diffusion. Okay, let's move into the algorithm. Okay, so we are going to take 64 bits, that is one block, as a plain text. Okay, so the first step is initial permutation. So what is meant by permutation process? Permutation means transposition. So transposition, the thing is that we are going to interchange the bit position from one location to another location, or in other words we can say jugglery of bit position, we can say, or transposition of bit positions, we can say, or interchanging of bit position. That is called as permutation. Okay. So first step, that is IP is representing the initial permutation. So in this first step, you can see the picture. So plain text is given as input as 64 bits. So upon doing the initial permutation, permutation means transposition. Transposition means interchanging of bit position. Okay, fine. So this 64 is divided into 32 bits. 32 bits. Okay. So 32 bit at the LPT means left plain text and RPT means right plain text. So 32 bit is divided into 64 is divided into 2 times 32 bits. Okay, fine. So this initial permutation will happen only once before the first round. Okay. So round in the sense, in the second step you will be performing round. So each round will be consisting of 16 steps. Fine. So before the round you have to go for doing the permutation process. That is to be happen only once. Okay, fine. So it suggests that how the transposition in initial permutation should proceed. So for example, you can say, so here you can see this picture at the left side. Input block is 64 bits. Now we are going to do the initial permutation. So 1 to 64 bits are depicted here, and these 64 bits, first bit is going to replace with the sixth bit, and second bit is going to replace with the third bit. Likewise, some interchanging of bit positions happen. At the end, you are going to have the output block of 64 bits. Fine. So this is the first step, that is initial permutation step. So at this step, you are going to perform the interchange the bit position. That's all. Okay, fine. So after the initial permutation is done, the resulting you will be getting 64-bit permuted block. So that 64-bit permuted block will be getting as the output. That is going to divide into two 32-bit blocks. So one is left plain text, the other one is right plain text. Fine. Okay. Now the second step is we are going to perform 16 round on these two blocks. Okay. Now we'll get into the second step. So already we have seen first step 64-bit is divided into two 32 bits. One is left plain text consisting of 32 bits and the right plain text consisting of 32 bits. Okay. So this is the output of the initial permutation. Now we are going to get into the second step. So that is the key transformation step. Okay, fine. So key already we have seen out of 64-bit the key length the algorithm is going to use only 56-bit. Okay. So for each round we will be using this 56-bit. So from this 56-bit a different 48-bit is going to be generated. Fine. So at this step we are going to generate a key. So normally the algorithm will use the 56-bit key length is 56, that will be transformed to 48-bit. Subkey is generated. And this subkey is generated during each round using the process called key transformation. So for each round, a key will be generated. 48 subkey will be generated. So this process is called as key transformation. Okay. So here in this picture you can see 56-bit is divided into two halves. So each half is consisting of 28 bits. Fine. So this keys, that is these halves are circularly shifted left. For example, if you are taking 1010 means upon having the left shift, so this 1010 will be shifted to left one shift. Okay. So we'll get this bits. Okay. One bit left shift will be done. Okay, fine. So after an appropriate shift, these 48 of this 56 bits are selected. Okay. So upon 56 bits, it is converted into 248. Sorry. Yes. It's converted into 48 bits. That is, we are going to divide into 228s. The thing is that 56 is getting into 48 bits. Okay, fine. So the key transformation process involves permutation. So as well as the selection of the 48-bit subset of the original 56. So at this step, 56 key bit is converted into 48-bit subset. Okay. So this is called as compression permutation. So 56 bits is getting compressed into 48 bits. So make clear that the plain text you're taking is 64-bit. Okay. At the step 2, So the key length going to be used is 56. So out of 64, we are going to make use of the key as 56. So with this 56 bit, it is going to get compressed and converted upon the compression process. Will be getting 48 bits. So we call this as a compression permutation process. Okay. So this is called as key transformation. Fine. So the next step 2.2 is expansion permutation. So expansion means, so what is the result of the key transformation? 56 bit is compressed into 48. So 48 bit is the output of this key transformation. That will be given as input for the expansion permutation process. Okay. So here now we are going to look at the RPT, that is left right plain text. Okay. So what is this? The plain text 64 bit is divided into initially two 32 bits, two halves, that is each carries 32 bits. Okay. Now we are going to consider this 32 bit RPT. Okay. So here at this step 2.2, 32 bit RPT is going to be considered. Okay, make clear that. Okay, so this 32 bit RPT is going to get divided into 8 blocks. So each block is going to consider consisting of 4 bits. So 8 into 4, 32 bits. Okay, fine. So here you can see, now we are considering 32 bits of RPT. That is right side of the plain text. So we are not taking into account of the LPT. We are coming into the RPT, that is right plain text, which is consisting of 32 bits. Okay. So this 32 bit is going to divide it into 8 blocks. Each block is going to have 4 bits. Okay, fine. So each 4-bit block is then going to expand. Okay. So what is the process called? Expansion permutation. Now we are going to expand this 4 bit into 6 bits. So the input block will be containing 4 bits and the output block will be containing 6 bits. So this 4 bit is going to get expand to get the 6 bits. Okay, fine. So here this picture, input block first. So 4 bits that input block will get into the same thing. 1, 2, 3, 4 will be getting like the same bits. The first and 6 bits will be getting from the adjacent blocks. So see here, the output block of the 6th bit of the output block 1, it's getting its bit from the second input block of first bit of the second block, second input block. Okay, so that will be coming into the 6th bit of the first output block. Okay, and coming on to the first bit of the output block, this comes from the last bit of the input block. Last block is 8th block, and last bit in the 8th block will become as the first bit of the output block. So in this manner, every output block is getting first bit and 6th bit from their adjacent input block. So considering the output block 2, so 1, 2, 3, 4 from the input block will become as such for the output block. The first bit in the second output block will be coming from the last bit of the input block 1. And the last bit of the output block 2 comes from the last block of the first bit that comes into picture. So in this manner, the 4 bits in the input block is expanded to get the 6 bits in the output block. So this is called as expansion permutation. So initially we are having 8 into 4, 32 bits is converted into 8 into 6, 48 bits. So 32-bit RPT is get expanded into 48-bit RPT. So at this juncture, may I stop. If you are having any queries, you can ask or able to follow any response. May I have any response? Say yes or no so that I can proceed, or I can explain again. Am I audible, or is the screen is visible?
Yes, ma'am. Visible, ma'am.
Is the process is clear?
Yes, ma'am.
Okay, fine. Thank you.
Thank you.
Okay. So at this expansion permutation, we are dealing with the only the 32-bit of the RPT. Okay, fine. So this 32-bit is divided into 8 blocks. So each block is going to have 4 bits. So that is get expanded to have 8 blocks. In each block, you will be having 6 bits. So 8 into 6 bits, it is get expanded as 48 bits. So 32-bit is expanded to get the output of 48-bit RPT. Okay, fine. Let's move on to the next step, 2.3. Okay. So, before moving to the 2.3, expansion permutation is first we will be performing key transformation. So key transformation compresses the 56 key bit into 48. Okay, fine. Then the expansion permutation process, what it will do? It will expand the RPT, that is right plain text 32-bit is converted into or expanded into 48 bits. Okay, fine. So at the end of this key transformation, 56 is converted into 48 bits, that is compression is carried out here. So you'll get the output as 48-bit key. Okay, fine. So in the step 2.2, expansion permutation, we are going to deal with the RPT, that is right plain text. 32-bit is RPT is going to get expanded to 48-bit. So you are getting the output 48 RPT. So right plain text. So these 48-bit key and the 48-bit RPT is combined to perform a XOR operation. So the output is fed as input to the PBox substitution, that is your step 2.3. Okay. So with these two results, you are going to perform the XOR operation. Okay. The resulting output is given to the next step, that is PBox substitution. Fine. Let's move on to the step 2.3 PBox substitution. Okay, fine. So what is X representing? Substitution. Fine. So what is PBox substitution is? It is the process that accepts the 48-bit input from the XOR operation involving the compressed key and expanded RPT and produce the 32-bit output. Okay, fine. So this is your 48-bit input block. Okay. So this 48 is going to divide into 8 blocks. Each block is going to have 6 bits. Okay, fine. Now this 6 bit is converted into 4 bits. So 6 is now getting compressed to 4 bits of each box. That 4 bits is called as PBox 1, PBox 2. Okay, fine. It goes up to 8 box. So 48-bit input is converted into 32. 8 blocks of 4 bits means 8 into 4 will be getting 32 output block. So in the Xbox substitution, 48-bit is fed as input. It is get compressed and getting the output as 32-bit output block. Fine. So this 32-bit output block is fed as or it is given to the next stage of the round, that is PBox permutation. P is representing permutation, S is representing substitution. Okay. So what happens at PBox permutation? So we are getting the output from the Xbox substitution as 32 bits. So that will be given as input to the PBox permutation. Okay. So the output of the Xbox consisting of 32 bits, these are permitted using the PBox. What is meant by permutation? As we have seen, permutation means transposition. Transposition means interchanging of the bit positions. Fine. Or in other words, we can say swapping of the bits. That is called as permutation. So one bit is swapped onto the another bit. So input block consisting of 32 bit, upon applying the PBox permutation, there is swapping of each bits without any expansion or compression. So no expansion or compression is carried out as here, only the swapping process is carried out here. So you will get the output block of the same bit. So whatever the bits you are having, 32 bits, you will be getting the same output block also. So this is called as PBox permutation. So you are getting the output of 32 bits. Okay. Next, move on to the next step, 2.5, that is XOR and swap. So now we are having, so far we are performing all these steps with the RPT only. We didn't even go for the LPT. So write plain text of 32 bits only. We are considering doing all these steps: key transformation, expansion permutation, Xbox substitution, PBox permutation. Okay, fine. So what happens with this step 2.5? We are going to perform the XOR operation and the swapping operation. See here. So initial permutation IP is divided into 32-bit LPT and 32-bit RPT. So here with this IP we are dividing into two 32 bits. Okay, fine. So and we are only taking into consider this 32-bit RPT and performing all these steps. So we have not touched the LPT. Okay. So here at the step 2.5, so we are going to consider this 32-bit LPT, do the XOR operation with the output of the PBox permutation. Fine. So now, as a result of this XOR operation, you will get 32-bit RPT will be get as the output of 32-bit left LPT block. Okay, and upon doing the XOR operation, the resultant will be taken as the 32-bit RPT. Okay, this is the new outcome. Okay. See here, the result of the XOR operation becomes the new write-off RPT, and the old write-off. What is the old write-off? This is old write-off. Okay, and this becomes the new left LPT. This is called swapping. So at this step 2.5, so you have swapped these two. Okay, fine, and you have also performed the XOR operation. Fine. Okay. So we have done these step 2.1 till 2.5. So this will be repeated 16 times. So for each round, these 5 steps has to be performed. Okay, fine. So what is the step 3? So you have to go with the final permutation process. Okay. So at the end of the 16 rounds, so for each run you have to perform all these 5 steps repeatedly, and for you have to do with 16 times you have to repeat all these steps. Okay, fine. So at the end of the 16th round you have to perform the final permutation. That is to be performed only once. So initial permutation should be happen only once. Likewise, final permutation should happen only once. So this permutation, as I told, the permutation means just simply swapping the bits or transposition of the bit positions or interchanging the bits. Okay. So for example, first bit is going to change with the 6th bit or like that. 40th input bit takes the position of the first output bit and so on. Likewise, you have to interchange it. So the output of the final permutation will be the 64 bit. Okay, that is your ciphertext. So in this manner, you have to do the data encryption standard algorithm. Okay. So as encryption is the reverse process of decryption, the same algorithm is used for decryption also. So the algorithm is reversible. Okay, fine. So what is the only difference between encryption and decryption process is that the reversal of the key portion. That's all. For example, if the original key was divided into K1, K2 up to K6, so make a note of this. At each and every round, you are going to generate the key. So, for example, at the first round, you are going to generate the key 1K. That is K1 is the key. So, if you are performing 16 rounds, then 16 keys will be generated. So, K1 up to K16 will be generated. Okay. So, that is 16 encryption round will be performed. Okay. So, at the decryption side, the key should be used in the reversed manner. That is K16, K15, K14 goes up to K1. Just you are going to reverse the key alone. That is, the key should be reversed in case of decryption. That's the only difference between encryption part and the decryption part. Fine. So coming on to the strength advantage of DES, the inner workings of the DES algorithm are also known to the general public. So therefore, the strength always lies in the key part. Okay, so which is maintained as secret. So DES uses only 56-bit keys. Okay, so that is the possible keys. These number of possible keys can be used. Okay, fine. So this, it seems that no brute force attack cannot be applicable on the DES algorithm. So what is going to be brute force attack? That is, already we are saying brute force attack means trial and error method. So upon the hacker can go on applying this brute force attack on the any plain text, and they can go for retrieving the plain text. Okay, when the conversation is going on, but this is impossible with this DES algorithm. So why so? For each and every round, the key is generated. So for 16 rounds, 16 keys will be generated, which will make more complex for the intruder to get back the plain text. So that is the main strength of the DES. Okay. So here, brute force attack on this DES algorithm is impractical. Fine. So let's come on to the variations of DES. There are two major variations. That is where two major types of DES are there. One is double DES and the other one is triple DES. So we are having two more further classification in the triple DES. The first one is triple DES that uses 3 keys, and the second one is triple DES with 2 keys. We'll see how the double DES works. So double DES means you're going to apply the DS algorithm twice. Fine. So it does twice what DS normally does only once. Okay. So here double DS uses two keys, K1 and K2. Fine. It performs DS algorithm at the original plain text. Here K1 is used for encryption process and you will get converted into ciphertext. And again, once again, you have to apply the DS algorithm for encryption with the help of the K2 perform the encryption and convert into ciphertext. So what double DS means? You are going to perform 2 times encryption upon applying the DS algorithm, and at the first time on applying the DS algorithm, you will be using the K1 key, and on the second time you will be using the K2 key. Okay. So the original plain text, it's encrypted twice. 2 times you are performing the encryption. Okay, with 2 different keys you need to perform the 2 times encryption. That's the concept of double DS. So coming on to the triple DS, there are 2 variations are there. The first one is triple DS with 3 keys. So triple DS means you are going to perform 3 times DS algorithm. Okay, 3 times encryption is going to happen. Okay. So for the 3 times encryption, each time you are going to apply the DS algorithm. Okay. 3 times means 3 keys has to be used. So at the first time DS algorithm, you will be using the K1 key, and at the second time encryption, you will be using the K2 key, and at the third time you will be using the K3 algorithm. So this is the triple DS with 3 keys. For decryption, the reverse process. Okay. First you have to use the K3 key, and you have to use the K2 key, and you have to go for decrypting. K1 key will be used. So encryption process, K1, K2, K3 will be used for 3 times encryption, and for decryption process you have to reverse the keys. That is, K3 will be used for the first time decryption, and will be used for the second time decryption, and K1 will be used for the third time decryption. That's all. So 3 different keys are used. Okay. Coming on to the next variation in triple DS is triple DS with 2 keys. Now we are going to perform triple DS with 2 keys, K1 and K2. Okay. So far we are saying only encryption is alone carried out. Okay. With case of double DS, 2 time encryption is carried out. And triple DS means 3 times encryption is carried out with 3 keys. So this is what a somewhat different one. So here 2 keys are used. See here with the original plain text, DS algorithm is performed with the help of the K1. It is get converted into ciphertext, and you have to perform the decryption here. So the major difference is here. Decryption is carried out. Okay. For the decryption, you are using the different key, that is K2, and it will get converted into ciphertext 2. Again, you are going to perform the encryption algorithm DES upon applying this DES algorithm for encryption with the same K1 key. Okay. So key K1 is used for encryption and K2 is used for decryption. So that is the only difference between the previous types. Okay, right? So at last you are getting the ciphertext. Okay. So far we have seen symmetric key cryptography algorithm, that is data encryption standard DS algorithm. Okay, and we have seen what are the variations in DS algorithm also. So what is the problem with this symmetric key cryptography is that the problem is that exchanging
of keys, or in other words we can say how the keys are shared between the sender and the receiver. That is key distribution